when I say, hey, we know the derivative of sine is cosine, right? But what's the derivative of inverse sine? So we talked about derivatives of inverse functions yesterday, but inverse trig functions have these special rules. Does this not look terrible? Oh my gosh, here's what I'm going to do for you. You ready? Well, we're going to cross off two of them. You don't have to know two of them. But again, they're in calculus rules, but AP's not going to ask you about two of them. But first, I want to kind of show you what the heck we're talking about. So if I say, hey, what's the derivative of inverse sine? Like, I'm here to tell you it's this, which is crazy. And we're going to just prove it a little bit, see where it comes from, just to help ourselves a smidge. Here's what I want us to do first. Let's draw ourselves a little triangle. And we're going to put our little angle down here as y. And what we do know is the sine of y is x. That's what we're going to just start with this statement. Anyone miss my lightsaber? This blue arrow is no fun, correct? Much better. Okay. Sine of x is y. If the sine of y is x, sine is always opposite over hypotenuse, right? So if this was a right triangle, the sine of y is opposite over hypotenuse. You cool if I just label that as x over 1? Sine is opposite over hypotenuse. Okay, they didn't ask us about that, but how could I rewrite? If you remember how we get y by itself, like an angle by itself, can we say that that's the same as inverse sine of x? Do you guys remember that? In order to get an angle by itself, you can't divide by sine, but you would inverse sine it. So I'm just going to remind us that these are equivalent. Equivalent. They're the same thing. It's just like me saying, hey, first period, everybody get a new seat. We're still the same class. So they're asking for the derivative of inverse sine. But if it's the same as this one, and I'm more comfortable with that, I'm going to go with this. Let's go find the derivative of the sine of y equals x. So I'm just going to write it again just to help myself. I'm going to have a piece of candy for anyone who can tell me the derivative of sine of y. Dang! Did you know it too, Coop?
Yeah.
Cosine of y, dy dx. The fact that you remember that dy dx was huge. Coop, what's the derivative of that x going to get me?
1.
There you go. If we want to go ahead and get dy dx by itself, could we divide by cosine? So you're right. Dy dx equals 1 over cosine of y, which it would be secant. Agreed. What I want us to go from here, and again, would I ever expect, and is AP ever going to ask you to do this proof? No, I just want you to see where some of this came from. The cosine of y. If I want to do cosine in terms of adjacent over hypotenuse, so COT, I got to find this adjacent. I want to go ahead and just name this A. And how would I find that leg? How would I get A? Like A squared plus B squared equals C squared? You know what I'm down? Are we down with that? Can we do a little A squared plus X squared equals 1 squared? And 1 squared is the same as 1? And then I want us to get A by itself. So I could say, all right, A squared is the same as 1 minus X squared. And therefore A is root 1 minus X squared. And I'm just going to put that over here. Root 1 minus X squared. I just put that in for my A over here. Okay. So I'm going to take this. And now I need to replace, instead of saying the cosine of y, what could I replace that with? I'm going to say dy dx equals. Actually, let me just put it this way. I'm going to say dy dx equals 1 over
1 minus x squared.
Cosine, so adjacent over hypotenuse, would be square root of 1 minus x squared over my 1, right? Over my hypotenuse, which I don't need to put something over 1. This is the derivative of inverse sine.
Everything goes back to geometry.
You're right. You're right. Quick reminder, inverse sine is the exact same thing as arc sine. They are the exact same thing. AP uses both of these terms. Inverse sine, inverse cosine, arc tangent, things like that. They're equivalent. Whoa. So notice this. Here's what we got, people. Derivative of inverse sine. This is the exact same thing as this. And you're like, what are you talking about? Look what they did here. They're saying if my angle is u, the derivative of inverse sine is 1 over 1 minus the angle. Notice that this u squared is just saying take this angle and square it. But then can anyone tell me what you think that du dx is?
Because you're taking the derivative
Of
u.
the angle. So this is like chain rule. What? Let me say this one more time. You're going to do 1 over square root of 1 minus this u, you just square it. But then you have to multiply by the derivative of that u. You're like, I'm sorry. These look crazy. I want us to just look at derivative inverse cosine and inverse sine. Do these kind of look similar?
Yeah.
What's the only difference you see?
A negative sign.
Yeah. So that's like one rule that we got to memorize, but we got to remember cosine is negative. And then I want you to look at tangent versus cotangent. Tangent versus cotangent. Same thing?
And
One's negative. Which ones are negative? The ones that start with what letter?
C.
C. That's how I like to remember it. The cotangent and the cosine are going to be negative of the tangent and the sine. Let's put this into use. Here's the deal, y'all. The derivative inverse cosecant has this absolute value of the angle. Guys, we don't have to worry about this one, and we don't have to worry about that one. Let's practice this. Let's practice what the heck all that was about. I personally, if you are given this, I think it's important. Let's just rewrite it that they're asking for the derivative of inverse tangent. That's the exact same thing. You don't have to rewrite it, but if you're good with that, you're fine. If you're good with how they wrote it, don't worry about it. So, which of these rules am I going to use? I'm going to use the derivative of inverse tan, which is this one. Inverse tan is my favorite because there's no square roots and there are no minus or negatives. This one's my favorite. So, derivative of inverse tan, it goes 1 over. So I'm going to just say I got 1 over 1 plus the angle squared. What was my angle? What was my u, if you will? X cubed. So you could write it just like that. And then what do we need to multiply it by? This du dx is the derivative of this angle.
3x squared.
The derivative of this angle is a 3x squared. If you end there, Rai, you're good. Q, you might take it a little further. You might say 3x squared over 1 plus x to the 6th. 3x squared is really just over 1, and I could multiply straight across. And then when I've got a power to a power, I would multiply those exponents. Yeah? You down with that, Koopy?
Yeah.
Okay. But, Tatum, you finish right here. We happy. Sound good? This one here is just saying, hey, what's the derivative of inverse sine? Do I wish that it was just like inverse cosine? Yeah, but it's not. Derivative of inverse trig functions have these fancy rules. Which one? A, B, C, or D? This is really just a matching game.
D.
It's going to be D. What's this one, the derivative of? Inverse cosine. Make sure we say that inverse. Sound good? Okay. Ooh! This then, annoying, is saying, here's the function g. The function is inverse sine of x over 2. What is this asking for without technically using the what? The derivative. That is just asking for the derivative. This is the formal definition of the derivative. So if here's my function, this is saying, hey, go find the derivative and then go plug in what x value? Yeah. Okay? So here's my function. I just want to point this out. Is this the same as inverse sine of 1/2 x? Are these equivalent? Boom, shakalaka. Are those the same?
Yeah.
Yes. Okay. Let's go use my derivative of inverse sine rule, which is right here. So that means take 1 over, so I'm going to say the derivative, g prime of x, is 1 over square root 1 minus the angle squared. I'm going to leave it as x over 2. I just wanted you to know that they were equivalent. So look what I just did. I put that little u right here, and I squared it. But then I still have to multiply by the derivative of that u, du dx. Now, couple different things. If I was Biscuit, I love my Biscuit, but he would do quotient rule here because he sees division, and you would do quotient rule, and we'd get the right answer. But if we think of it this way, you don't have to do quotient rule. You know what the derivative of 1/2 x is. What's the derivative of 1/2 x? 1/2. So we could just say, oh, the derivative of x over 2 is just 1/2. Would my man Biscuit still get 1/2? Yes, because he would say low d high minus high d low all over low low. And then you say 2 minus 0 over 4, and he'd get 1/2 as well. So you can totally do quotient rule right here. Or if we're like, oh, 1/2 x is the same as, x over 2 is the same as 1/2 x. The derivative of 1/2 x is 1/2. Either way. Sound good? All right, so that is my derivative. And then where do they want that derivative?
Root 3.
Yeah, when x is root 3. So I'm going to go plug in a root 3 for my x's. And I'm going to say the g prime of root 3 is 1 over square root 1 minus root 3 over 2, square that, and I still have this times 1/2.
And you can leave it there.
We could leave it there, but let's just push ourselves, okay, Coop?
Okay.
Okay. On top, 1 times 1, I'd get a 1 on top.
Yeah.
On the bottom, I'm just going to kind of focus on this for right now. What's going to happen when I square a root 3 over 2? Just do them separately. Root 3 squared. Yeah, 1 minus root 3 times root 3 is 3. 2 squared is 4. And I still have that times 1/2 chilling. Could I write this? Or is that equivalent to, I'm going to write it as this. Is that equivalent to 1 over 2 root 1 minus 3/4? Could I put this 2 out front?
Yeah.
I can, because there's just 1 times 1 on the top, 2 times that square root. You're allowed to put that 2 right out front.
Okay, couldn't you simplify 1 minus 3/4?
We better. We better.
Yay.
Mr. Richards, how are you?
I'm on top of the world.
That's a great way to be. Q, you agree that 1/4 minus 3/4 is going to get me 1/4? Is that right?
Yeah.
Okay. Can I split that up and say, well, what's the square root of 1/4? Square root of 1 and the square root of 4 is going to get me
Square root of 1 and over
It's just 4.
square root of 1 is
1,
square root of 4.
4,
Careful. Square root of 4?
2.
2.
So it's 1.
Oh, I see what you're saying. You're just jumping to the final answer. 2 times that 1/2 is going to get me 1. Final answer. Holy smokes. But we could have ended here for AP. People, we got this. Derivative of inverse tan. It's my favorite because there are no negatives and there are no square roots. What do we got? 1 over 1 plus. What's my angle? Cosine. We got to square it. Could I write it like this? Yeah. If we forget chain rule, we end here. Yeah. Derivative of my cosine. Yeah, derivative of cosine is negative sine. And I'm good. We good? Let's end it. Okay, this is again putting kind of things all together. If the arc cosine of 3x is ln, again, you might be like, arc cosine? I'm just going to remind you guys, that's just inverse cosine. And they're asking, hey, what's the derivative of this? We can do it. Inverse cosine. We haven't done this one yet. We haven't used this equation. Here it is, up here in blue. What are we going to start with? We've got a -1 over a square root of 1 minus, what's my angle?
3x.
Yeah, I'm going to take a 3x in parentheses. I'm going to square it. That was this part. We still have to multiply it by du dx. What's the derivative of that angle? 3. So you could write it like this, you guys. Or you could just say, well, wouldn't that technically just go up top? So you could just put that 3 up top. Henry might even just say it's not -1 times 3. It's the same as just -3. Any of those are great. I'm good with any of that. Sound good? That right there was the derivative of this side. Be careful. What's the derivative natural log of y? Nice, you guys. Derivative natural log is always 1 over its component here, and then times the derivative of y, which is a dy dx. Whoa! They want us to get dy dx by itself. What would we need to do? Dividing by... Perfect. Dean said dividing by 1 over y is the same as multiplying by its reciprocal, which is just multiplying by a y. So therefore 1y and y cancel out. And I'm left with negative 3y over square root of 1 minus, I'm even going to simplify it, 9x squared. And that's going to equal dy dx. Could we have left it like this? Sure. I just want to remind you that that y was really over 1. So if we multiply it across, this is how we could simplify it the most. Here we go. What's this one asking for? What's this one asking for? It's asking for the derivative. It's this right here. It's asking for the derivative. Here's the function they're telling us. And again, if you don't like it written like that, that is the same as inverse sine. Okay, that's my function. This is saying, hey, go find the derivative. What's the derivative inverse sine of x? We're going to use this. We're going to say, all right, the derivative, f prime of x, is 1 over square root 1 minus my angle squared. And instead of a u, I'm going to put an x. Then what would du dx be if my angle was x? Agreed. It's just 1, so we don't have to worry about it. You guys, where did they want that derivative? Because this is not an answer. Yeah, they want it when x is a half. So I'm going to go say, all right, f prime of a half is going to get me 1 over square root 1 minus 1/2 squared. And Coop, this is kind of why we practiced this on the last one, because we got to be simplifying these square roots.
And 1/4, because 1/2 times 1/2 is 1/4.
1/2 times 1/2, or 1 squared is going to get me 1, 2 squared is going to get me 4. 1 minus a fourth. 4/4 minus 1/4. 3/4. Guys, is that the same as root 3 over root 4 on the bottom? We can always split up those roots. So 1 over root 3, what's root 4 going to get me? 2. Yeah, well, dividing by root 3 over 2 is the same as multiplying by 2 over root 3, the reciprocal. So this would be 1 times 2 over root 3. Is that an answer? Boom. Last one on this page says, hey, what's the derivative of inverse tan, I love inverse tan, of e to the x? All right, inverse tan is 1 over 1 plus the angle, which was e to the x squared. But then we got to multiply by du dx. Here's u. What would du dx be? What's the derivative of e to the x?
E to the x.
Yes. Is that an answer?
Yeah, it's A.
Do we agree it's A? Yep, I agree. Here it goes. On the AP test, they said, hey, what's the slope of the tangent line to this curve, which is inverse tan? Here come my rules again. So do we just have to have these memorized? Yeah, it's kind of the worst. Arctan is the exact same thing as inverse tan. So if that helps you to write it that way, go for it. If you're like, nah, dude, I'm good. Great. Inverse tan of 4x. What's the derivative? That's just going to get me 1 over 1 plus that angle squared. They are expecting you to stop there, but you're going to say, no, no, my friend. What do we have to multiply it by? 4, the derivative of that angle. Awesome, you guys. Boom. They said, hey, what's that slope? We just found the slope. But then they said at the point where x is a fourth. So we got to go plug in a fourth here. So I'm just going to say I'm going to analyze that when x is a fourth. So now I got 1 over 1 plus 4 times a fourth. You can write that there. Or you could just say, if I know 4 times a fourth is 1. Whichever helps you, I'm good with. But that's just me plugging in that fourth right there. 4 times a fourth is just 1. What's 1 squared? 1. 1 plus 1 on the bottom is going to get me 1/2 on the bottom times that 4. Final answer, 2. Mar, were they expecting us to leave off that 4 and get a final answer of a half? Sure. That's an option there. You know what I'm saying? They are ready for us to forget chain rule. This one here says, hey, does this again the formal definition of the derivative? Yeah. But look at this time. They're telling us that it is 2. Huh. They're saying that the derivative is 2. Well, what's my function? What's my function? Yeah, say it again, Ritzy. Oh, I thought you said arcsine. Maybe it was Bob. Was that you, Bob? Nothing. My goodness. Arcsine of A is going to be my function. And you're like, wait, where did she get that? It's right here. Sorry, Riley, I'm hovering you. It's always just f of x plus a minus f of x. That's my function. This is asking what's the derivative? What's the derivative of inverse sine? Guys, it goes back to this. We're going to say, all right, the derivative, f prime of x, is 1 over square root 1 minus the angle. What was the angle in this case? It was just an a squared times the derivative of my angle. The derivative of a is just like the derivative of x, which is just 1. They're saying which of the following could be a value of a. So we got this derivative, and we need to say, hey, that derivative equals 2. And I got that info from right there. And then we're going to go solve for a, people. This derivative equals 2. That came from right here.
We can multiply that by 1 minus a squared.
You know it. He's saying, let's get rid of that denominator, which was square root of 1 minus a squared. These cancel. And I would get 1 equals 2 root 1 minus a squared.
Now we're going to square everything.
What do you want to get rid of first? Yeah, let's get divided by 2 first. Sound good, Coop?
No, yeah.
All right. Now I'm ready to square stuff. Now I'm ready to square stuff. Guys, there's a reason this is the second last problem on this topic. I think this is a hard problem. 1/2 squared is 1/2 times 1/2 is going to get me 1/4. A square root squared will cancel out, and I'm left with 1 minus a squared. Then if we subtract 1, 1/4 minus 1, or 1/4 minus 4/4, negative 3/4 equals negative a squared. So could I say positive a squared is positive 3/4?
Yeah.
By dividing both sides by -1 or multiplying both sides by -1. And then to get a by itself, we got a square root. And I'm going to separate it. Square root of 3 over square root of 4 would be the same as the square root of 3 over 2. Whoa. Give this one a shot. They want the derivative of arctan, which is inverse tan. It's my favorite. Did we already do this one? Inverse tan is 1 over 1 plus the angle squared. Don't forget the derivative of the angle. They're waiting for you to do it. What's the derivative of cosine? Negative sine. Is that an answer?
Wait a minute.
Is that A? Were they waiting for us to forget this part?
Yeah.
Oops. They sure were, and that would have gotten us E's answer if we forgot our chain rule.